Hello everyone, welcome to a new video. In this lecture, we're going to talk about SQL or SQL intro. So we're going to cover the basics of what is the meaning of SQL, how to use it, and we will go over a couple of examples. Okay, so first, before we get started, it's important to define some key concepts, such as database. So what is a database? Pretty much it's a system that has a purpose of storing, managing, and retrieving data. So in SQL, we will create, and we will store data in databases. So there are different types of databases. The focus of this lecture will be on relational databases. So every time we talk about relational or SQL, I want you to think about structured data. So that's pretty much tables. So every time you're talking about tables, like the table that you have seen in Excel, in Power BI, or if you have used SQL in the past, so you're familiar with this type of tables. And later in this course, we will talk about non-relational data. We will see different structures, and in which we call NoSQL, not only structured query language. So here we have different structures where in some cases you have like nested tables and different data shapes, different formats. So again, the focus of this couple of weeks will be mainly in structured data. So SQL is a language. It has been around for more than 50 years. It's popular, and it's kind of like very important if you're working on analytics, if you're a data scientist. For sure you need to know how to do some SQL, because most companies, they have their data stored and managed using SQL. So again, it's a standard, it's very popular. That won't change. Like in the near future, it's going to remain the same. So it's very popular again. Okay, so one of the advantages of SQL is that it is a declarative language. What is the meaning of that? Declarative means that when you're coding here, pretty much what you say is, or your prompt or your code, it's okay. I want this data, but you don't have to tell like how you're gonna get that data. So it means that it's like a prompt, right? But of course there is some codes, there is a language that you need to understand first in order to get the answer right. So there are different tools that you can use to write SQL and to manage databases. So the most popular are MySQL, even Postgres. Postgres is also very popular, and of course there are other options. In this course, we'll be using Postgres because it is important that we're consistent. Even though SQL is pretty much the same, regardless which of these we are using, there are some differences, like small differences in the codes, and especially in the compatibility when you're creating the files. And even though it's possible to, to transfer one file to make it available for another platform, it's a mess, like if I start doing that from the beginning. So I will try to stick to Postgres in our course. But again, if you are familiar with the other tools and you know how to handle all of this, it's fine. It's not mandatory. Okay, so some key concepts. So tables are really important, of course, because it's where we store our data. So in the columns, we have the fields or the variables, and the rows, we will have the observations. So it's a tabular format. We have keys in order to establish relationships among our different tables. So this is how it looks, like a data model. So here we have different tables, and in each table we have different variables or fields, right? And we have here the connections, right? How each table is connected to each other. And we have keys, and that's how we are able to connect those tables, right? Using the keys, for example, here in jobs, we have job ID, and here in employees, we have job ID. So we can connect that, like using this variable. All right. On Postgres, it's important to know this hierarchy. So we have that we can create databases. So if we have database, imagine that this is like a container where you're going to store your data. But inside the database, we can create schemas. So you can create multiple schemas if you want. And inside each schema, we will have tables and views and some functions or procedures. So in this course, initially, we will be working with databases, schemas, and tables. And later, we will develop some views, right? And we will explore all the possibilities. So just for the moment, remember this structure because we're going to use it in our problems and in the homework. Remember, you have the database, then the schema, and then the tables. Okay, so there are multiple, of course, commands. Even inside SQL, there are like different languages. So you have the data definition language, data manipulation. Now, for the purpose of this class, for sure you will learn how to, like create tables, databases, schemas, how to alter them, how to drop them. Also, for data manipulation part, you need to insert some, like rows, to delete or update depending on the application. This is very useful on a daily basis. When you have a database and you are inserting new data, imagine a transactional database. So every time there is a transaction, so you need to, manipulate the data in order to update the information. What else we're going to use? Of course, data query language to select the data that we want. We need some functions, aggregate functions to compute metrics. So sometimes we will need to count some, compute the average, the max, the minimum. In other cases, we need to group by. I know you are familiar with group by, especially when we're using pandas or even in R. So this idea is, the idea of the group by is to use one variable or more variables to group our data. So when you want to compute some metrics, but you don't want to compute the metric with all the observations, you can group by a variable or by a subset of variables in such a way that you get the metric for each group, right? We will use the having, the order by, where, of course, and or between, all the condition. This is for, logical and to evaluate some conditions. And this is really important when we have multiple tables. In some cases, we need to join our tables in order to, like answer some specific questions to get some specific data. So it's important to get familiar with the different joins. We will discuss most of them in this video. So here we have some basic functions. Insert, when we add new data in the table. Select, when we're creating the data. So select means, okay, which columns you want to see or which metric, if that's the case. So let's go over some examples. So in the first example, we want to display all employees from the sales department. So imagine that we have a single table right now, and there is one variable or one field that the name is employees, and there is another one that is department, right? And we want to see all the employees that belong to a specific department, to sales. So we start with our first operation, the select, right? So we need to pick. Now, then you need to specify, okay, what do you want to select? So if this table, it's possible that you have the name, like the last name, also, all the information that you might have from the employees. But if you, let's say you want to retrieve like all columns, so then you use the multiplication sign, the star. This is a star that will give you all the columns from employees. That will be our table. That's the name of our table, employees. Where, that's the other command here. Department, which is a variable, it's equal to sales. Right? You might have different departments under this, like a variable or under this column. But for this specific query, we want to list the employees from sales, right? So of course we will get the output is going to be a list or a table with the employees from the sales department. So before we move to more examples, let me show you real quick the joins. So you have multiple joins. For example, the first one is the left join here. So A and B, they are tables. So when we perform a left join, it will give us all the information from A and the matching information from B. If we do a right join, it's the opposite. We get all the information from B and the matching information from A. If we perform an inner join, it will give us only the information of the matching, like keys from A and B. We also have a full outer join to, like when we want to join the two tables completely. And we have, some options when we use the null and things like that. So let's go over some more specific examples. So let's combine now two tables. So remember, inner join retrieves only matching records. Left join all records from the left and the match ones from the right. So in the example here, we have two tables. We have the table employees and the table departments. Now, we want to display the employee's name and their department. So in the previous example, everything was in a single table. But now in this one, we have two separate tables. Now, be aware that here we have a variable. This is going to be our key that we can connect the table because we have the department ID and we have the ID here. So using this like variables, we can match, we can join our tables. So this is the solution. So we want to select from the table employees name, right? This one. So we want to see that. In addition, we want to see from departments, the department name, this one, right? But remember that they are in two separate tables. So from where we're going to pick, we're going to select that information is not a single table. We need to join them. So from employees, this one, and the inner join with departments, the other table, and we need to specify how we're going to do the join, right? So our keys will be the department ID from employees and the ID from the departments table. So once we do that, then this is the output that we get. We get a table with the name and the department. So this is a simple join, an inner join in this case. Let's check one more theoretical example, and then we will move to use some code. So aggregations, these are functions to compute metrics: sum, count, average, max, mean, and there are more, of course. Group by, we want to group our observations based on one or more variables. And having is for filtering aggregated data. So let us go over an example. In this one, we have the employees table, and the idea is to find the departments with an average salary greater than $50,000. Okay, so it's the average salary per department. So we need to, that's the first thing that we need to find, right? Department, and also what is the average salary per department. So it's not the average salary for all the observations. No, it's per department. So we need to group that. We need to group by department, right? In order to be able to compute that metric for each value of for each level of this variable. So this is a solution. So we want to select, this is what we want to see at the end, right? What we want to see the department. We want to get the average salary, right? From where? From the table employees. Now, remember, if we don't group here, the average salary will be the average salary for the whole table, and you don't want that. What you want to see is the average salary per department. That's why we group by department to get this metric per department. Now, there is one more comment here or condition here. We want to visualize only, or we want to get only the average salaries that are greater than 50,000. So if we just have our query until the group by, we will get the average salary for the whole company, for each department in the company, but we don't want that. We want to add this condition here. Only average salary is greater than 50,000. Then this is when we use our having, right? The average salary greater than 50,000. So this allows us to add this condition. So what we get is, this is an intermediate step. This is the average salary. This is when we group. But then when we apply the having, That's where we get, the final output, which is this one. Only the departments with an average salary greater than 50,000. Okay, so now let's go to write some code. So I'm using a Visual Studio, VS Code. Again, this is not mandatory, it's up to you. It depends, like what you want to do, it's up to you. But what I like about the VS Code integration with Postgres, and also the ability to, like to create some Jupyter notebooks or some code, some Python code, is that everything's in the same place, right? So that's one of the things why I like this. All right. So the first thing that we're going to do here is that we need to bring the data, the schema. So I'm assuming at this point that you have installed, you have VS Code, you have installed also Postgres, the Postgres extension. This is the elephant that you see here, the Postgres SQL, Microsoft Postgres SQL. This is elephant here, and that you are connected to the local host. Once you do that, you will see only one database, the Postgres database. You can create more, but initially you will have the Postgres database. And that's where I'm gonna put, like our data. So using the terminal here below, I'm gonna bring, like all the data for the example that I'm gonna create right now. So in the terminal, the code that I'm using is this one, PSQL. So every time you use PSQL, it's the way in which you communicate from the terminal to Postgres. Here, the U means the user. So by default, I'm using the Postgres user. The D is for the database, which database I'm using, Postgres. If you want to change, to a different, I have two more, like employees here and prayer, which is test. So I can use these other databases if I want, but again, I'm going to put it here in Postgres. And then I'm going to run this file, chapter2 schema.sql. So that file, you will find it, on Brightspace. In this file, we are providing all the tables, all the schema that we need for the following examples. So with this code, you run it in your terminal. You're gonna be the only thing is like you need to consider, okay, where is this file located? In which folder is this file? The chapter2 schema.sql. Once you know where it is located, in your terminal you need to define that. So this is my path. So you can change the path. Remember that to find it. Every time you wanna see where it's located, you can also copy the path. Like just right click the file. This is the in this case chapter2. The chapter2 schema. So we need to find it here. Here it is located for me, and we can copy the path in case like you don't know it. I'm here, so I'm just gonna run this code. So once I do this, it's asking me for the password, which is really important that you remember when you are during the installation of Postgres. So I'm typing the password right now. So once it is done, it will run the chapter2 schema. So it will create all the tables. I can show you that. If I go to Postgres, look at this. Right now, it's not chapter2 is not here. But if we update the schemas, if I refresh that, let me refresh the database too, and then the schemas. Okay, so now we have chapter2, and in chapter2, you can see that there are some tables, right? I'm going to use these two tables, the inventory levels and retail sales. That's what I'm going to use in the example. Okay, so this is an SQL code for the queries. But if you need to, like if you want to type a new script, you just create a new file here. Just give the name .sql. Oh, this one already exists. And now you can type some SQL here. Of course, you will need to connect this to your server. So when you click here, it says disconnected. So right now I'm going to connect it to the local host. is connected, and then if you can also change the database. In my case, I'm going to use Postgres, the Postgres database. But if you have more, it's up to you. Like you can pick a different one. All right. So I'm gonna stick to this one. I'm already at Postgres. It's connected. So let's explore. Let's explore our database, which is called inventory levels. It's located in the chapter 2 schema, right? So let's visualize everything. So to visualize everything, remember is select from. Let me increase a little bit the size. Like this. Okay. So let's gonna select everything from the table inventory levels. So let's understand what we get here. So pretty much we have an item ID, the name of the item. So we have some product, laptop, smartphones, tablets, the price, and the stock level. That's what we get. And then there are some questions. So let's go over some of them just to practice. So what is the total stock level of all items in the table? So we want to put all of them together. Like how many units we have, in our warehouse. So it's a sum, right, of the variable stock level. This one. This is optional. You can provide a name for that metric. So if you don't do that, then the label is going to be the same as the metric, like sum of stock level. So it's up to you. And then of course you're going to get that from the inventory levels table. So let's run it. And we get that there are the total stock is 510 units, right? Let's explore a couple of more options. So what is the average price of all items in the table? So instead of sum, now it's average, right? And if you want, you can round it. Okay, so it's similar, right? We're just changing the aggregation function. Instead of sum, we're using average here. Okay, so here we have what is the name and price of the most expensive item in the table. So we don't know that, right? We need to compute. We need to get that. So we need here a subquery. So we want to select the item name and the price, right? And we know that we want to get that from the inventory labels table, but we need to use a condition. So where the price is equal, and here we have a subquery. So this subquery is going to get which is the maximum price. So in the subquery, we're going to select the max price from our table, for inventory tables. So in this subquery, what we're getting at the end is just which is the value of the maximum price. So once we get this value, then this condition is going to be applied, where price is equal to the maximum value, right? So at the end, of course, we will get the answer. So it's a laptop in our database. Okay, here is a similar question. What is the name stock level of the item with the lowest stock level? Maybe you want to reorder, something like that. You want to see if there are some values, like maybe below a reorder point, if that's the case. So again, this follows the same structure. What we're changing here is instead of price, we're using the stock level. But I guess, you get the idea, you follow the idea. It's pretty much the same thing, right? So let's check one more for this example. So what is the name and stock level of items with stock level less than 10? So maybe again, this is like a reorder point. So if you have a policy, let's say that if the stock level is below, like a threshold, then you're going to trigger an order. It's going to trigger, like a decision. So we can compute that, right? So we select the item name and the stock levels where we have this condition. Execute that. So we get the products, right? The items with a stock level below 10. All right. We can, keep working with different functions such as the order by. Here, what is the name and price of the 5 cheapest items in the table? So you want to order by the price because you want to get the cheapest. in ascending order. So you want your table from the minimum to the maximum value. So if you keep it like this, just the first two lines will give you, like the whole table for every single product. But the question is the top 5, right? The 5 cheapest items. So you can limit your table only to 5 observations. So it will give you the 5 cheapest items. So if you run this, it will give you, the 5 cheapest items in your database. All right. So this is for the first for this example. Now let's check the second table that we have, and this is more related with the book, where there are some specific ideas to profile a table, to visualize like some of the information. Okay, so let's get familiar first with the table that we're going to analyze. Is retail sales. It's in the same schema. Remember, when we ran the chapter to schema, what we did is like pretty much we loaded the schema chapter 2 with 2 tables. Okay, so let's explore our new table. So here we have sale ID, the dates of the sale, the store, product ID, quantity of the transaction, the price, the category of the product, discount percentage, total sale, and the region. Okay, so here we have some, let's say that we want to get like more information about the variables, what type of variables they are. So we can perform this query here, select the column name and the data type. So that will give us the fields and what type of data. From the information schema columns, where table schema, it's the name of the schema chapter 2. The table name is retail sales. So this query is going to give us like a general information, right, of our variables, right, in that specific table. We can perform like a profiling. This is like it looks like a descriptive descriptive analysis. So here we want to know just like how many observations there are, number of rows, for the date. Remember there is a date for each transaction. So maybe we want to know the range, right? Like the minimum date and the maximum date. So with min and max. And remember as is for labeling, right? The outputs. And how many stores we have, right? So let's count distinct stores, like how many different values for that field, for that variable. We also want to count the categories. So this is to get like a quick profiling, right? About the volume, like how big is our data, the variability, like to get an idea of the complexity. So this is our summary, right? Using SQL. Let's do 2 more before we go to a Python, to Jupyter Notebooks to be more specific. The distribution profile by category and region. So here we want to get more information per region and per category. Imagine this is like a pivot table. This is like a pivot table. So let's see the output. So here we're grouping by category and region. So for each category and for each region, for each combination of them, we want to get like number of transactions, number of units, the average price, right? Maybe some metric like the median value. That's possible, all of this. So this is like it's like a pivot table in Excel or Power BI. So here you have for category home and the region south. There are 2,000 transactions, 5,165 units. The average price was equal to 99.55, right? And we have the median here. The median value. It splits our data set into 2 equal parts. We can do some binning here to summarize the prices and revenue. So we can analyze so here we're going to select, for the select, we're going to create a price bin. And what are the values for that price bin? So if the price is under 20, that's the label. If it's between 20 and 49, between 50 and 99, or if it's 100 or above, right? So we want to see the total sales for each bin, for each of these branches that we have defined here. So we define the price bin. Again, this variable is not in our dataset, but we're creating that using this case. And now we can use it even for the group. We can group based on the price bin. So we want to count the number of transactions, and we want to compute the total revenue for each bin. Okay, so let's run our query. So here we get our table, under 20, between 20 and 49, 50 and 99, and 100 or more. And this is the total revenue and number of sales for the units for each of these bins that we have defined. So this is another way in which where we can summarize our data. And we can keep working here. This is another pivot-like summary. So where we can see for each category and the different regions, we can see the revenue, right? Again, this is a typical a pivot table where in the rows here we have the categories and in the columns we have the regions, and the variable of interest is it's going to be the revenue. Okay, so this is just SQL so far, but now this is the interesting part, because at the end of the day in this course we're interested in doing some machine learning, some data analysis. Of course this is analysis, but we want to use some of the tools that you have learned like throughout your this program. So how we're going to do that? So that's the nice thing about if we're working in VS Code. So we just go to our files and we can create a new file, which is a Jupyter Notebook or a Python file. That's up to you. I have one here already. Now, the libraries, you're familiar with the library that I'm using here, Pandas for data manipulation, Matplotlib and Seaborn. In my case, they are for visualization. The only new library here for you is going to be this one, SQL Alchemy, this one. Especially we are importing the create engine, and this is going to allow the connection with the database. So in order to connect with the database, we need some information, and of course you need to add this specific information depending of the parameters that you have set during the installation of Postgres. So the username, Postgres, the password, this is my password, so be careful, do not use the same password. This is just for the video. So you need to remember the password that you use during the installation process. The host, we're using the local host, right? Because we're running it in our computers. So it doesn't matter if it's like a Windows or Mac. In general, the default port is going to be this one, the 5432. In some cases, if you're using that port already for another application, then the next one is the 5433, most likely. The database, in this case, I need to change it, because what the name of the data says in my case is Postgres. Okay, so with the parameters, so we connect, right? We run the engine. So pretty much this is gonna create a connection with our database. That's what's happened. This is the important thing. So once we are connected, once this is working, so this is simple. So you just type the queries. So here I'm typing the query. This is the same syntax as SQL. So here we're getting the distribution by category and region. So we select category, region. What else? We're counting the rows. We have the sum of the quantities, the average price, same thing that we did, like in the previous script. From the tables, we're grouping by category and by region, and we're ordering that information. So this is the query. So the important part here is that we are getting this table from the query into a data frame. So once you do that, now you know what to do with that data. Right? This is the important thing. This is the only new part. These two things. First, we added the SQL Alchemy. Then we connected with the database. And then once we're connected, we can run any query, like using SQL. Once we get the data, we can transform the data to a data frame. And remember that in pandas, like in Python, we're working with data frames, or you're familiar working with data frames. So now you can do like anything. Like if you want to create a dashboard here, if you want to, like run some model, like, supervised learning or unsupervised learning, scikit learning, you can do anything here. Because now you have a data frame and you're familiar with it. You can, create some plots here. I have some plots just as an example. But during the homework, I will ask you to create models, like a supervised model or unsupervised model. But the only important part is how to connect to the database and make sure that you get your, like your data frame. And that's it. Then you know how to do the rest. Okay? So I'm going to stop the video for now. I'll see you in our next lecture.